Once again, warm greetings on a very bright day. This is data structures, and today's class we will discuss about data structures algorithm, the various stepwise refinement techniques, and about the modular programming. So this is one peculiar way of structuring programs. So that also we will discuss about data structures in today's class. So this is especially for you, my dear students and young researchers. And this is Dr. Professor Christo Ananth for you, and you can reach me at dr.christoananth@gmail.com. So thank you, God, for giving me this golden opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants. And as for you, you thank God, for keeping us safe and healthy these days. And even though there is dip in the number of cases, but still COVID has not gone completely yet. So this particular class we'll discuss much more about the stepwise refinement techniques. We'll discuss about the programming style, the significance of using imperative programming, and about the various steps that is needed to develop a modular program. We discuss about two types of modular programming, which is top-down modular programming and bottom-up modular programming. And then we discuss about the structured programming, the object-oriented programming techniques. We discuss about the pseudocode with the specific examples. And then we discuss about the second part of today's class, which is steps to effective stepwise refinement. And then the refinement step, especially dedicated for while loop or maybe do while loop. And then we tend to declare an initialized variable. Of course, we have posted independent work in the Google Classroom. So please complete them at your best possible time within 1 week. And we have at regular intervals some short videos to explain the knowledge in our topics. So here are the stepwise refinement techniques. Generally, we are going to write an informal algorithm. It's not formal algorithm, but it is informal algorithm. We tend to write it only if we have an appropriate mathematical model. And if we have a mathematical model, we can write an informal algorithm. Generally, with the case of informal algorithm, we can have general statements, which means it is a set of informal instructions. We are going to convert this informal algorithm into a formal algorithm, which means more definite instructions can be written to by applying any programming language syntax and semantics partially. Finally, we are going to develop a program by converting this formal algorithm by a programming language. So which means that there are several steps to reach a program from the initial mathematical model. So there are some conversion steps. This conversion steps you call it to be refinement techniques. So here are the stepwise refinement techniques. So we are going to convert the informal algorithm to a program, and we have to pass through several stages of formalization until we arrive at a program, which means that you are going to formally define with the help of a programming language what you call it to be the stepwise refinement techniques. So from mathematical model initially, from an informal algorithm, you are going to convert into a formal language, which is a pseudo language program, and from there you are going to convert to a data structures or maybe C programming or maybe C++ programming. So we have like several steps in order to arrive at a final conclusion. So the first stage, which is modeling, we try to represent the problem using an appropriate mathematical model, maybe like a tree or maybe as a graph. And here the solution of the problem is an algorithm expressed in an informal way. So at every stage you are going to do that, and in the next stage you are going to write the algorithm in pseudo language or maybe formal algorithm. So this pseudo language will be a mixture of any programming language constructs and lesser formal English statements. Okay, so pseudo program is just in this way, and here the operations to be performed on this type of data is fixed. Okay. And finally, in the final stage, we choose an implementation for each abstract data type, and you write the procedures for the various operations. Okay. Here, the remaining informal statements are replaced by a C code or maybe C++ code or any other programming language. So these conversion techniques, you call it to be the the refinement techniques or stepwise refinement techniques. Here in the case of programming style, we have 4 programming styles. Okay, we have procedural, modular, structured, and object-oriented programming. With the case of procedural programming, it is a paradigm based on the concept using procedures. So procedure is a sequence of commands to be executed, and any procedure can be called from any point within the general program, okay, which includes like other procedures or maybe that procedure itself. Okay, so it will have like concepts, okay, some sub programs, methods, or maybe routines. Okay, so procedure means set of instructions, step by step it has to be executed. Here are the applications of programming styles. Like maybe in the case of programming, this procedural programming can be used in large-scale projects. Okay, so we have like something called reusability of piece of code called as procedures, and it's very easy to understand the logic of the program using this procedural programming, and you can easily maintain this code. This emphasis is on doing the things, or maybe the emphasis is on algorithms, and most of the functions they share global data. It is not about local data, it is sharing the global data, and here data moves from function to another function, and this function is going to transform data from one form to another form. So this is procedural programming. So with the case of imperative programming, only from imperative programming comes procedural programming, because each step of the computation is described explicitly by means of defining procedures. Similarly, we see in the diagram, the main program plus data, it is divided into procedure A, procedure B, and procedure X. Procedure B, you are going to simplify into procedure Y and procedure Z. So everything has some procedures, everything is divided into steps of computation. So here in the case of the modular programming, generally the program, it is being decomposed into sub-modules, okay, so different modules, and the program can be written in the modular form, which allows an overall problem to be decomposed into a set of individual sub-programs, which means that this module, okay, this program divided into different modules, these modules divided into sub-modules until it cannot be further decomposed. So the sub-module, which is located anywhere in the program, and the superior module, whenever necessary, can make a reference to the subordinate module, okay, and they call for its execution. So when the superior module is going to call its subordinate module, the superior module is said to be the calling module, and the sub module which is going to be called is called as the called module. I hope you understand. Okay, so this sub module can be sub programs such as functions or maybe procedures, which is going to be called out by the superior module. There are some general steps that is needed to develop a modular program. So first of all, you have to identify the problem, or maybe you have to define the problem, and you have to generalize the steps which is needed to achieve that particular goal or objective. Now you are going to decompose this problem into subtasks, and you are going to prototype a subprogram for each subtask. You are going to repeat this step 3 and step 4 for each subprogram until you are going to decompose the problem into subtasks, prototype or subprogram for each subtask until further decomposition seems counterproductive. So here in the diagram you see main program data. This you are going to split up into module 1 and module 2. So module 1 you have data and data 1. Module 2 you have data and data 2. Okay. With this data and data 1 you are going to go with the procedure 1. Since this is somewhat big, okay, you are going to give split it into procedure 2 and procedure 3. But everything comes part with the main program. Okay, so this is modular programming. So modular programming, we can also say that it is a procedural programming, heavily procedural, okay, and this focus is entirely upon writing the code or maybe designing the functions. It is not about the data. It's not about the data, but it's all about writing code or maybe how you write the functions. So modular programming discourages the use of control variables and flags used in parameters, and their presence is going to indicate that this caller needs to know too much about the function that is being implemented. It doesn't care about the data. Okay. So here there are two methods which are used in modular programming. One is top-down approach and another one is bottom-up approach. So whether it is top-down approach or maybe bottom-up approach, the end result is actually a modular program. Okay. So here the end result or the final result is very, very important, because not all errors can be detected at the time of initial testing, which means that there are still some errors in the program, and if that error is being discovered after complete testing, which means that this module concern can be isolated and it can be retested. Okay. Suppose like if you have maybe a fever and they have applied some injection, okay, still if you maybe get some fever or maybe cold or maybe cough, you might be isolated. Once again you are going to retest. So this is modular program. So regardless of the method that is being used, and if the program has been written in modular form, which means it's very easy to detect the source of the error and you can test it in the isolation mode. Okay. So there are several advantages of using modular programming. It is going to reduce the complexity of the entire problem, and you are going to avoid the duplication of the code. Debugging program is much more easy and reliable as well. It is performance oriented, so which means it is going to improve the performance. And modular program, it is going to hide the usage of the data structure. So that's a peculiar characteristic of modular programming. And global data is also hidden in the module. Also there is reusability in the modules, like there is no need for rewriting and no need for retesting as well. And then it is going to improve the portability of the program and it reduces the development work. So these are the advantages or maybe characteristics of this modular program. And then you have the top-down modular programming. So just the name implies top to down. So here the principle is all about a program should be divided into a main module and then related modules, and each module should be divided into sub-modules according to that programming style or maybe software engineering. So the division continues until the module consists of the elementary process that can be easily understood and it cannot be further subdivided. So same thing, the definition remains the same, but top-down approach. So you have the top-down algorithm design. You have module 1, module 2, module 3. Module 1 is divided into module 2 and module 3. Module 2 is divided into module 4, module 5. Module 3 you have module 6. So here in the top-down algorithm design, it's a technique for organizing and coding the programs in which a hierarchy of module is being used, and you are going to break the specification down into more simple pieces. Each of them will be having a single entry point and single exit point, and which means that the control is passed downward through the structure without any unconditional branches to the higher levels of the structure. So it is top-down design. So it is going to generate modules which is based on the functionality normally in the form of maybe methods or maybe functions or maybe procedures. So this is top-down approach. And then you have a bottom-up algorithm design. So it refers to the style of the programming where an application is constructed starting with the existing primitives of the programming language, and generally it is bottom up. You are going to start from the base. Okay, you are going to build them up to ending the top. So the bottom up method is widely used for testing because each of its lowest level function is written and then it is tested first. So which means that this testing is done by using special test functions, what we call it to be the lower level functions, and you are going to provide them with different parameters and you are going to examine the result for correctness. So whatever we do, we start from the base and then we end at the top. So that's what I told you. Once the lowest level functions have been tested and to be correct, which means that the next level of functions can be tested. So since the lowest level functions already have been tested, any detected errors are probably due to the higher level functions. So generally the process continues. Like 4, 5 and 6 is being tested, and afterwards 2 and 3 is being tested. Finally module 1 is being tested. So this process is going to continue until the main function like module 1 is being tested. So this is bottom up modular programming. We are going to go with structured programming. So just like modular programming, it is also a programming style, but the thing is that it should have like several names. So we have procedural decomposition or maybe structured programming. Okay. So structured programming means it is not generally about structures, but the thing is that we tend to use different code structures to write programs. So we have a sequence of sequentially executed statements, and we have conditional execution of statements, okay, like the if statements, and then we have a looping or maybe iteration. We have the for loop, while loop, do while loop, and so on. And then you have structured subroutine calls, what you call it to be functions. Okay. So this is structured programming, which is coding of structures to write the programs. So there are some parts that which is actually forbidden in structured programming. In particular, you cannot use the go-to statements or maybe the break or maybe the continue statements out of the middle of the loops, and you cannot have multiple entry points or maybe multiple exit points, like multiple exit points to the function or maybe procedure or maybe subroutine. You cannot have multiple return statements, and you cannot have multiple entry points to that function or maybe procedure or maybe subroutine or maybe method. And in this particular style of programming, there is greater risk that the implementation details have to be shared between the functions and it is globally exposed. So this is one major drawback of structured programming, because the structures of these functions are being exposed globally. So which means that other functions can use the implementation details. So there is unwanted dependencies between different parts of the program. So this is a part that has to be considered. So there are advantages and disadvantages of structured programming. The disadvantage is that all decisions which is made from the start of the project depend directly or maybe indirectly on the high level specification of the application, and it's a well-known fact that this specification tends to change over time, and when this happens, there is greater risk that larger parts of the application needs to be rewritten, because somebody tries to copy means it has to be rewritten, it has to be modified, but this modification comes from the external function. So that's the problem. Okay. And there are some advantages as well. We have clarity. We have the structured programming which has better clarity and logical pattern to their control structure, and due to the tremendous increase in the programming productivity also. Also, as another key to the structured programming is that each block of code has a single entry point and single exit point, which means that we can break up longer sequence of code into modules. and maintenance, the clarity and modularity inherent in the structured programming is of great help in finding the error and redesigning the required section of code. Okay. So this is the major advantages of using this structured programming. And now we get in touch with the object-oriented programming. It is completely different from the structured programming. And here in object-oriented programming, we tend to remove the flaws which is encountered in the procedural or modular-based approach. And here, object-oriented programming, we treat data as a critical element in the program development, and it does allows it to flow freely around the system. It is going to connect this data close to the function, and it is going to protect it from the accidental modification from the external function. But with the case of structured programming, the modification happens from the external function because they try to get the copy that functions out of it. So this doesn't happen with the object-oriented programming. So object-oriented programming, it allows decomposition of that particular problem into a number of entities called as objects, and then you are going to build the data and function around these objects. So this is the image or maybe the diagram which is going to better explain with the case of object-oriented programming. So here we are going to organize this data and function. Here the data of one particular object can be accessed only by the function associated with that object. Okay, so we have the data and object, the data and the function of object A, which is communicated with object B. We have data and function. This data can be accessed only by the function associated with that object, and it can communicate with another object B. Similarly, you have a common intermediator, the data and function. Here the function of one object can access the function of another object. So this is organization of data and function in object-oriented programming. There are some salient features of using object-oriented programming. Here the emphasis is on the data, but in the previous cases the emphasis is on the function. Okay, here the emphasis is on the data rather than the procedure. Here the programs are divided into objects, okay, and here the data structures are designed such that they characterize the objects. Here the functions that operate on the data of the object are tied together in the data structure, and here the data is hidden. It cannot be accessed by the external function. But with the case of structured programming, it is accessed globally. It is globally exposed. But here it is hidden. It cannot be accessed by the external function. Here the objects can communicate with each other through the function, and new data and functions can be easily added whenever necessary, and it follows the bottom-up approach in the program design. Now we have a pseudocode. Generally, it's fundamental to the process of the stepwise refinement. So you call it to be the false code or maybe imaginary code. Okay, so it's a low-level design tool or maybe notation which offers the flexibility to write algorithms that we need not have to understand completely, but it is a imaginary code, a low-level code. Okay, a structured English. Okay, and you have like programming language like control structures. You have sequence, set of instructions one after the another, and then you have selection, okay, called as the if, and then you have iteration called as the while loop or maybe for loop. Here we will be having like descriptions of functions, description of data, and then you have a program style indentation and some statements for grouping and readable. You have some comment section also. So this is an example. This is an example of an election. Okay, void primary election. Within that, you read all the candidates. Okay, starting from primaries, and then for each of the state, you read the votes cast in that particular state. Okay, and you are going to assign the delegates to particular candidates. And again, within that, for each of the candidate, you are going to print the report for each of the candidate. you're going to close the brace. Okay, so this is how you're going to go with the pseudocode. Okay, so this is stepwise. Okay, so you are going to start with the initial problem statement, break down into few general steps, take each step and break it into some much more detailed steps until it cannot be subdivided. Okay, keep repeating the process on each step until you get a breakdown that is pretty specific and can be written more or less in pseudocode. You translate the pseudocode into real code. So problem statement is all about this one. Okay, you consider an example. For example, if you have to determine the class average for a set of test grades input by the user. Okay, so for example, whenever test grade is being done or maybe calculated, it is not known in advance because this user will have to enter a special code called as the sentinel value, and it is going to indicate that he or she has finished typing in the grades. Okay, so only if the user types in the grade means then they will be getting the individual grade, they will be getting the total grade, they will be getting the average grade. Okay, so this is for the the average grade in all of the subjects of that particular student, also that average grade about the total class. Okay, so this is how you're going to process the problem statement. So here in the initial breakdown, you are going to declare and initialize the variables. Next, you are going to input the grades. Okay, you have to enter the input. Next, you have to compute the class average, and then you are going to output the result. Okay, so what you are going to do? You are going to add the grades. You are going to count the grades. You are going to divide the sum by the count. Okay, now you will realize one thing. Before doing all this input, before the sum and the count, definitely we should have some variables. Only then you have to store. Only then you can compute the sum. You can compute the total. Only then you can compute the average. So what you do? You revise the breakdown of steps. So this is a revised breakdown of steps. First of all, you declare and initialize the variables. You input the grades and then you count and add them as they are being input. You compute the class average. Okay, now you break the steps into smaller steps. Okay, so which means the input step you have like you are going to break down in this way, like loop until user enters the sentinel value. Okay, and then user has to enter the grade. Okay, maybe you can give the needed information or maybe -1 to quit completely. Okay, and then type the grade. Okay, type the grade means that grade is going to be stored in one particular variable. Okay, and this grade you are going to add it up. You are going to add 1 to the counter so that you can track how many grades are actually present. So this is revised breakdown of steps. So this is refinement loop for a while loop or maybe do while loop. So which means we could specifically write this as a while loop or maybe do while loop. Okay, so this is how it goes. Do prompt user to enter a gate. Maybe they can give the needed information, or they can choose to exit, like -1 to quit. Allow the user to type in the grade, which means it is going to store in a particular variable, and you are going to add this grade into the variable used for storing the sum, and you are going to add 1 to the counter to track how many grades are present. And if the user has not entered the sentinel value, then you can go for -1. So which means that we realize that adding and counting steps should only be done if the user entry is a grade. So if the user entry is not a grade means, so which means it is going to exit. So we are going to do one more refinement. Okay, so do prompt user to enter the grade. Okay, user to type in the grade. If the entered value is a grade, okay, only if it is a grade, you add the grade into the variable used for storing the sum, and you add 1 to the counter. So this is the extra step you are entered. Okay, only if it is a grade, you add the grade into a variable used for storing the sum, and you add 1 to the counter to track the how many grades have been entered. And if the user has not entered the sentinel value, then you are going to exit. So this is all about declaring and initializing variables. So the breakdown, you see that you declare and initialize the variables. So you initialize the variables, you have a grade variable to store the user entry, you have a sum variable, you have a counter variable. So grade variable, you are going to store the user entry. Sum variable, it is initialized to 0. Counter variable, you are going to initialize to 0. So sum, as and when the user inputs, sum is being calculated and counter is added, okay, to track the number of grades. And the compute the answer and print step. And finally, after doing all this stuff, you are going to divide the total sum by the counter and you are going to store the result. Then you are going to print this result. So this is all about declaring and initializing the variables. So finally, we can summarize in this way. You are going to initialize the variables and you have a grade variable to store the user entry. You have a sum variable. Initially it is 0 and then you are going to compute the sum automatically. You have a counter variable, it is going to add 1 to the counter. It is going to track the number of grades. It is initialized to 0, okay. And the grade entry. So the grade entry, you are going to prompt the user to enter the grade. It will be giving the needed information. The user has to type in the grade. This grade is actually stored in a variable, okay. And if the entered value is a grade, only then it is going to add the grade into the variable used for storing the sum, and you are going to add 1 to the counter to track how many grades are present. And when the user has not entered the sentinel value, then you are going to go for -1 and then exit. After doing all this one, you compute the average. You are going to divide the sum by the counter and you are going to print the answer. So this is how you are going to print the grades. After printing all the grades, you are going to go for the sum and the average. So I hope you would have understood, with regards to breakdown of steps and revised breakdown of steps. Okay, so we have independent work, sorting, problem of sorting, common sorting strategies, and then hash tables. Please complete your independent works at the best possible time within 1 week.